Hello everyone, welcome to this KOSEN Physics Part 4. And yeah, this is a question about waves. Now, the displacement y of the wave traveling in the positive x direction is described by the time t, and position x of a medium y is 3 sine 2 pi 0.5 t minus 0.25 x. Okay, so this is your general wave equation, and it asks us what is the equation of the propagation of the crest, and choose the correct answer. So basically, equation of propagation is that when you have a wave like this, okay, the wave is progressive, so it's actually moving that way, but we have to find the wave of the propagation of the crest. So this is the crest, so we have to find the equation of its movement. So basically, we got the equation here, the general wave equation, and you see that the highest point that this equation can reach is 3, right? Because the maximum of sine, any sine, is at 90 degrees. I mean, the maximum value of sine is 1, right? So the maximum height is 3, okay? And then we multiply that, so sine pi t minus 0.5 pi x, right? And you divide that, cancel this, sine pi t minus 0.5 pi x. Then you know that sine 1 is sine pi over 2 in radian. So because you have made that, pi over 2 is pi t minus 0.5 pi x. Okay, and now the pi can be cancelled out. Okay, so that is half equals t minus 0.5 x. So 1 is 2t minus x. Therefore, the equation of propagation is x equals minus 2t plus 1. Okay, looking at the option there, wait, I think it's 2t minus 1, x 2t minus 1. Okay, so the answer is option A. And now for part 2, find the displacement y of the standing wave that is obtained by the superposition of another wave function, that is 3 sine 2 pi 0.5 t minus 0.25 x. That is our general equation from the first. And there's a second wave of 3 sine 2 pi 0.5 t plus 0.25 x. So basically, you have two waves, right? And this is your first wave. Okay, and you have the second wave, that is 3 sine 2 pi 0.5 t plus 0.25 x. So basically, this is a different wave, and you have to find the superposition of each other, which means, let's say the wave is going like that, and this wave is going like that, and this wave is actually combined and make a superposition. So basically, in this case, we just need to add the function here. So you just add everything. So 3 sine, and we just need to add it. So 3 sine 2 pi 0.5 t minus 0.25 x plus 3 sine 2 pi 0.5 t plus 0.25 x. Okay, and now you get here, you can factorize that. So sine 2 pi, maybe you can multiply that, so that is pi t minus 0.5 pi x plus sine pi t plus 0.5 pi x. And you see that now you have two sine, and you know that the identity, let's say this is alpha and I said it is beta, the identity is 2 sine alpha plus beta over 2 cosine alpha minus beta over 2, right? So you can just change that into 3, okay, times 2 sine alpha plus beta, that is 2 pi t, and this is cancelled, so this 2 pi t over 2 cosine alpha minus beta. That is pi t minus pi t is cancelled, but minus 0.5 pi x minus this, it will become minus pi x over 2. And you can see that this has become 6 sine pi t, and you know that cosine negative will be also cosine. Okay, so that is cosine 0.5 pi x. And just look at the type of option you have there. That is the option C. That is y equals 6 cosine 0.5 pi x sine pi t. Okay, so that is the answer for number 2. And now the question number 3 says that find the position of the node of the standing wave solved above. Choose a correct answer below. Okay, so basically from the solution that we have, so y is 6 cosine 0.5 pi x sine pi t. Okay, so we have to find the node from there. Now, from this equation, you remember that because it is resulted into standing wave, or whatever superposition wave they have, the general form that we could take from this is a cosine kx sine omega t, which shows that the superposition of the wave has a free end node. So basically, if you have like a free standing wave, so basically let's say you have the end of the wave and this is the wave. When this wave is actually moving, the end will be moving. Okay, and from this we could actually find the formula of the node. The formula of the node is actually is 2n minus 1 over 4 times lambda. And if we were to ask about antinode, that is n minus 2 over alpha. And if you didn't have that form, let's say you ended up with this form, in a different question, you would find this node with the formula of n minus 2 alpha, and the antinode is 2n minus 1 over 4 alpha. And you can see that this is just reverse. Okay, you cannot just, you have to remember and understand this formula so you can use it very well here. And of course from this we are using this, so 2n minus 1 over 4 alpha. Now it didn't say which node that we have to find, so we just assume that it is actually the first node that happened. Here it didn't ask which node that we have to find, whether it is the first nodes or another node, so we just assume that we have to find the first node. So n is 1, that is 1/4 lambda, and we have to find lambda from this equation. You can see that k is 2 pi over lambda, and we have k here is 0.5 pi, so we have lambda is 4. So this is 1/4 times 4, which is 1 meter. The answer is option B. Okay, so that is for part 3. And yeah, stay tuned for another part, and hopefully you understand the solution.